Hey class, I just wanted to show you a little bit of how to use Statkey. We'll be using Statkey quite a bit, especially in this chapter, so please pay careful attention. I'm going to go through how to do problem 3.31. And so we're going to go to Statkey here. I already have it up. And we're talking about sampling distributions in chapter 3. So I'm going to click on the mean. The problem asks about the mean points. Okay, we get lots of different information here. Note up in this corner it says Statistics Grad School. I'm going to switch that to Ottawa Senators points. Question 1 is to take a random sampling of 5. So remember, with this resampling techniques we learn, we're going to use our sample and sample from it again in a way. So we're going to switch our sample size to 5. Again, I hit this here and changed it to 5. And I'm going to say generate one sample. And so I get a 28.6 as my mean. Now I'm just going to write that down here as my answer to part A. Part B says to do the same thing. Now if I hit generate one sample again, it'll actually generate the other sample, but it'll compute the average of the two. So I could either hover over this and get the new mean of 15.4, or I could hit reset and do the same thing. So again, I could have entered 15.4, or I might hit reset the whole thing and generate one sample, which gives me a 27.2 this time. So let's write that down. Notice that if I keep resetting and doing this over again, I'm going to get a whole bunch of different numbers. And that's kind of the point, is when you're resampling, it's random and you get some random numbers. So this time I get 24.4. If I hit reset and go again, I'm going to get 21. I'm resampling. Part C is to ask to find the mean for the entire population. Now, that's already provided actually up here. This is the population. So our answer would be 26.458. So part D is to give a rough sketch of the sampling distribution if we compute many sample means of size 5. Notice I can, if I hit this, I'm generating one at a time. I can generate 10 at a time by hitting this button, or generate 1,000 or 100 or even 1,000 samples. I'm gonna let's reset. Suppose I generate 1,000 samples. Notice what happens here. Our distribution looks roughly symmetric and bell-shaped, and that's no accident, and we'll see more evidence of that later. The mean across everything is 26.135, which is pretty close to the true mean of 26.458. Okay, so for this part D, I might list symmetric and bell-shaped. Of course, I'll have to write in complete sentences and all that when I actually enter in the work. Alright class, that's it. That's how you do problem 3.31. I hope this helps. And again, just for emphasis, these first two items are random and everyone will get slightly different answers, and I will certainly be looking for that. Alright, take care until next time.